Now let's talk about some properties of radicals. You can rewrite the nth root of a times b as the nth root of a times the nth root of b. Or you could rewrite that property vice versa. If you were given the nth root of a times the nth root of b, you could rewrite that as the nth root of ab. So for example, we have the 7th root of 49m to the 9th. So we could rewrite that as the 7th root of 49 times the 7th root of m to the 9th. Now, this guy is not in simplest form because the index here, in this case, is smaller than that exponent there. So if we wanted this in simplest form, you could rewrite it as the 7th root of 49 times m times the 7th root of m squared. The same works for division. If you have the nth root of a divided by b, you could write it as the nth root of a divided by the nth root of b. And again, that property works vice versa. If you had the nth root of a divided by the nth root of b, you could rewrite that as the nth root of a over b. Again, this example is not in simplest form because we have a fraction underneath the radicand. And so we could rewrite the cube root of 16 over 81 as the cube root of 16 over the cube root of 81. Again, this is also not in simplest form because we have a radical in the denominator. We will either talk about this in class or we'll work on it on tomorrow's notes. So a couple more examples here to simplify using the properties of radicals. This one is being multiplied, so we could put them together since their indexes are the same. That's a key point here. You can only put them together if those indices are the same. So we could write this as the square root of p cubed q squared. And then again, if we want this in simplest form, we could take out some of those p's. So it could be p square root of pq squared. And also, since we're dealing with a square root, we should put this p on the outside and the absolute value 6. For example, 8, we have the cube root of 32 over 75. So we could split that up as the cube root of 32 over the cube root of 75. And again, that is not in simplest form because we have a radical in the denominator. We could work on the 32. We know from our earlier factor tree from example 4 that 32 is the same as 2 to the 5th. And so we could rewrite that as 2 times the cube root of 2 squared, which is the same as 2 cube root of 4. And again, we can deal with this 75 down here, or for right now, we'll leave it along for the ride. And again, we will either talk about this part in class, or we'll talk about it in tomorrow's notes.